Hello friends, welcome to Notebook. In this video, we shall be discussing a very important topic, light and images. It is going to be a very interesting session for you as you shall be learning about the following topics. The reflection of light from plane mirrors, demonstration of light traveling in straight lines, and identifying the characteristics of images formed by plane and other kinds of mirrors. What is light? Light is a form of energy that helps us see. If you are in a dark room, you are unable to see only because there are no light rays reaching your eyes. Light travels in rays. When you open the windows in a room and let the sunlight in, you see the rays of sun. And one distinct feature of these rays are that they are in straight lines. Here we see the windows letting in sun rays in perfect straight lines. Same thing happens when you light up a torch. The torch shows the beam of light spreading out and yet only in straight lines. Now allow the beam of light to be intercepted by a surface. Say light is made to fall on a surface. The surface could be a wall or anything, but just a barrier that intercepts the flow. You will notice that when light falls on an opaque surface, it gets reflected. The beam of light gets reflected in straight lines but in reverse direction. Now, why did you hear me use the term opaque surface here? That's because on transparent surfaces such as glass or water, light rays pass through the medium and they are no longer reflected. You can only see reflection on opaque surfaces. In others such as glass, light passes. If it were not so, you could not have used glass to make bulbs that transfer light. So surfaces that are generally observed to reflect light are mirrors. Let's look at a plane mirror as an example. As a beam of light falls on the mirror, the shiny and polished surface allows reflection to happen such that the direction of light is changed. Rays falling on the mirror are called incident rays, and those that are reflected are called reflected rays. This is the fundamental law of reflection. Now, let me ask you a very basic question. What do you see when you stand in front of a mirror? You see yourself. How do you think this happens? The answer to this is the same law of reflection, because when light reaches the surface of the mirror and reflects back to your eye, you can see your own image on the mirror. It's the reflected rays that reach your eyes and you are able to see the image formed. What you see on the mirror is therefore your own image formed on a plane mirror. Notice that the reflected ray is traced backwards to a point that is inside the mirror, and that's where the image is formed. The distance of the object from the mirror is the same as the distance of the image from the mirror. Here d dash is equal to d double dash. One interesting feature of plane mirror images is that of lateral inversion. When you raise your right hand in front of the mirror, the image shows the left hand going up. So does the image appear wrong? No, it's actually the right hand as the image is laterally inverted. Clearly, there is an apparent left-right reversal, and this is called lateral inversion of images in plane mirrors. You will see other instances of your hair parted on the side opposite to your real part, and the mole is on the reverse cheek. So plane mirrors produce images that are of the same size as the object, placed at the same distance from the mirror, just as the object, and are laterally inverted. Since images formed are not real, that is, they cannot be shown on a screen, they are called virtual images. There are other kinds of mirrors as well. Mirrors that are not plane anymore. They are spherical. They could be concave or convex, and the images formed on these mirrors have different properties than plane mirror images. You will see that convex mirrors bulging out and concave mirrors bulging in, as they are specific portions of a rounded sphere. Convex mirrors are shaped like part of the inside sphere, and convex mirrors are shaped like outsides of spheres. Images formed on these mirrors have distinct properties when they are placed at different distances from the mirror surfaces. The side mirrors of cars is a real-life application of a convex mirror. A concave mirror is more often called a converging mirror, and a convex mirror is called a diverging mirror due to the nature of conversion of the rays falling on the mirror. In case of a convex mirror, notice that a virtual image is formed. there is no way to see the image on a surface, while in case of a concave mirror, image is real. Similar to mirrors, we also have concave and convex lenses. In this section, we shall discuss a bit about lenses. Their properties are once again different from mirrors. The concave lenses have two outer sides of concave shaped surfaces, and that's why it's called concave lens. For convex, the outer surface are bulging out, and hence the terminology. Our eyes have concave lens. It is through this lens that images are formed on the retina. Convex lenses get all the glory. They're used for magnification in cameras and in countless other devices. Binoculars and flashlights employ convex lenses to magnify objects and make them appear closer as an example of real-life application. A quick follow-through will give you the differences between concave and convex lenses. Concave are thinner in the middle compared to convex that are thicker. You'll observe that light rays diverge on concave lenses and form smaller images. Whereas in contrast, light rays falling on convex lenses converge and form bigger images that are therefore used in binoculars and flashlights. Real images are formed by convex lens, and concave lens usually forms a virtual image. Here is a concave lens forming a virtual image. Notice that diverged rays are actually traced backwards to form a smaller image. In case of a convex lens, the image is real and formed bigger than the object. This happens when the object is at a certain specific distance from the lens. Moving on from reflection of light, plane, concave and convex mirrors or lenses, you should remember that white or natural light that we see from the sun is a combination of 7 colors, and these colors can be split into the original versions with a prism. A prism shows light split into component colors and in the sequence in which it is shown. This is by way of refraction, which is a different phenomenon. After a heavy rain, water vapor droplets behave as prisms in the sky, and we are able to see the natural splitting of light as a rainbow in the sky. So, with this we come to the end of this chapter on light. Hope you have enjoyed the session. See you in our other videos. Bye.